8 should give us
And
16.
then
we're going to take the absolute value
negative 16
of the integral of the next
over
function,
3.
which is from 1 to 3. Which is exactly what we got on our calculator. Okay, so that's super great. But since we're looking at area and
those absolute
value signs, we
don't
just really
force
do
it to be
anything
positive.
except
So our area is going to be
force
positive
our
16
answer
over
to
3
be
positive.
unit. You don't have to worry about it.
Okay.
And so for the sake
Sorry
of
that
time,
it's so congested
I'm
in
just
there.
going to show you guys how
But
to
know
do
that
this
you
on
can
the
also do it on your
calculator.
calculator. Not a big deal.
By hand.
Okay,
So
and
we
then part
already
B
have this function right here. And if you
asks you to
and
go
then do
from x
space,
equals negative
go
2
down
to
to
positive
7.
2.
Our lower
So
limit should be 0.
for this one, sorry, that's
and
big.
our upper limit should be 1. And then it gives
parabola,
us this number right here, which looks like a rational number
axis,
because we have a repeating decimal after it.
Right here.
So
and from negative 2
exit out of your graphing mode. Click
is going to give us this
and then it'll
shaded
give you that same
region
number
right
that you just calculated.
with part of it
and then do the
above the
fancy
x-axis
frac
and
math
part of
enter
it below
enter
the x-axis.
to get our whole value.
Is
So our
0.
first integral should be
So now I'm going to
12.
split it up.
Excuse me.
Integrals. I'm going to have negative 2.
And then we want to add on the absolute value of whatever we calculate next. So we're going to go back to our graph. This time we're going to calculate
and I'm going to use those
integral
as my boundaries
from
for my
1
limits of integration.
to 3.
So
and it gives
now
us negative
I'm going to write out my integral.
2.667.
First, I'll have
So we're
going to
quit.
negative 2 to
We're
0.
going to second answer.
Of
we're going to get our value from the front. Do math enter enter.
dx.
And we should get
and then I'm going to add
8.
on my integral from 0
and
to
we put our negative
2
8/3 in absolute value so that we get a positive value for our area. And let's see here. So when we add this together, we want to find a common denominator.
She'll be fine.
The least common multiple of these two is going to be 3.
We have already conveniently done the
I'm going to
integral
add
from negative 2 to 0.
8, or I'm sorry,
it's 12. We know
so
that
then
that's
I
just
need
going
to
be
multiply
16
by
over
4
3, and we forced it to be positive because it was negative under the square root.
8 over 3.
And then I'm going to go ahead and just tell you to do it
will
on
give
your
me a denominator of 12
I know that you guys have practiced stuff.
integrate this.
Like normal, but you would
5
have
over
32
12.
over 3 right here.
8 times 4 is 32.
I'll go ahead and show you again on the calculator in case
over
you
12.
just want to see it again. If you don't, just skip forward in the video.
Over 12. So we would put the same function in
units
here.
Squared.
Use second calc. Go down to number
Should be
7 with the integral. My lower limit is going to be 0.
All right.
So that's the solution for 3. Pause if you need to
calculate it for
me,
but it gives me a decimal.
Figure all that stuff out for a second.
Click second answer.
And then number
I get
4,
my decimal
again, do math.
This is the
fancy
the
fourth
fourth
type,
and I get 32 over
function or fourth type of
and
question that we
then-
said we could apply
and
definite integrals
pause
to.
if I'm
So
going to
when I
going
add these
to
two things together,
draw this one out.
32 plus 16 is going to give us 48. There is a typo here. This y
divided by
3.
Y 48 over 3 happens
plus
to be
1,
16.
not y minus x plus 1.
Okay.
Y minus x plus 1 is not an equation. There's no equal sign in it.
don't forget your unit.
We're looking for the area enclosed by the graphs of these two curves.
Okay.
This is a
line
for that
problem.
Okay. Slope of 1.
I'm going to go ahead and pause
Y
this.
intercept of 1.
Go ahead
that it
and
should
try
intersect
the
the
y-axis
at
at
1.
The next video.
We're back.
Okay.
It should go up
Finishing
sort of like
up.
that.
Oh, that's so bright.
And then we have a
finishing up
quadratic function
these
examples. So when I did this the first time, I made a mistake. So we're just going to attempt to do this again and hope that this time I find my mistake.
And
let me we need to take this quadratic
and bright.
and we're going to plot this.
Okay, so for number 2,
it asks
us
to
positive
find the area of the region bounded by the curve negative x squared minus x plus 2. And
it's going to
go up,
axis.
and we're just kind of guessing what it looks like for now.
Our
curve is going to look what you would want to do.
Like
is
this.
You could either, as we said,
because
x
we have a
equal to
negative
leading
coefficient
minus 3,
meaning our
and
parabola is
solve
going to
for
face
those
down.
x values.
And then we're going to have
or you can
roots
just go ahead if it's
here and
calculator
there.
active.
And so what we're looking
graph
for is this area
each
right
of those
here.
functions. And also drawing this picture is always super important when you're doing one of these, just so you know exactly what you're looking for.
And you should see what
like
they
up
both
here
look like.
in our first example,
Okay, so
we were able to see that we
picture
had
wasn't
some
too
negative
bad.
area
It
and
looks
some
like
positive area.
they intersect more.
Okay, so let's figure
do a
out
better picture than I did.
what
but we're
these
gonna
two
calculate our
values are of these
intersections
roots so that we can
so
have
that
our
we
limits of
know
integration. In order to do this, we need to set
where
our
our
quadratic
functions
equal to
actually
0.
intersect.
So our first one is at -1, 0. So
Minus x
this 2.
We're gonna make a really big dot.
So now
to make
we
it
need
look
to
like it's
solve
on
this
the x-axis.
quadratic.
So
let's
at
see if it's
x equals
factorable.
-1
It's nice just
is
to get
where
this leading
our first
coefficient
one's
to
gonna
be
be.
positive again. It's a little bit
Calculate our
easier to
second
see and
intersection.
be able to factor in your head. So I'm going to multiply the entire
So
equation by
first
-1
curve,
and get
and
0
then we
equals
do
x
want to
squared
care
plus x
where we
minus
guess
2.
for these because
Now
I'm so
I
sorry,
can recognize
because,
that this factors
your
into
calculator
x
needs
plus
to have a
2
general
and
area
x
since there are
minus
2
1.
intersections.
I set
So
each of
this
those
one's gonna
individual
intersect at x
factors
equals 4.
equal to
Okay.
0.
And we're looking for the area between these two.
And I
guys.
should get that x equals -2
Okay.
and x
So
equals
our
positive
limits of
1
integration
are
for
my
this
two
are going to be
limits of
-1 and
integration. So
positive
x
4.
equals -2.
Remember,
is over
-1
here.
is smaller,
X
so it goes
equals
on the bottom.
positive
4
1
is
is
bigger,
right
so
there.
it goes on the top.
Okay.
And
so now I
then
have to
we
actually
want to look
integrate.
and see
Okay. Now I'm going to be really careful.
function
Make sure
is
I
on
don't
the
make
top
any
and which
mistakes.
function's on the bottom.
My lower
So this
limit is
line
-2 because
is the
that
one on top.
is the
It's
smaller
like the
number.
upper bound.
My upper limit
of
is
these two
1,
things.
and I'm integrating
And
-x
the
squared
quadratic
minus
or parabola is the
plus
one on
2
the bottom.
with respect to x.
Okay.
Now
So
you may ask,
we want to
Miss
take the
Roberts,
top.
down here we multiply by
It's going to
-1.
have like a bigger
Why don't you use this
area.
function?
We want to subtract
We
the bottom
did that
off from
only
it.
so that
So
we
it's
could
saying that we
factor.
want to
We want to
take
use our original
maybe
function.
this will work.
This right here
All of
is
this
not
stuff
equal to this. It just happens to
that's
be that when we
beneath
multiply by -1 on both sides of the
the
equation,
line, and then
we
subtract
still get the same
off
equality.
all
So
of the
we want to
stuff
use
that's
this guy right here.
beneath
the
the parabola.
when I
okay?
integrate this,
And so we're left
let's
with
see, my
just
power is going to
that
go up by
little
1, so I'm going to have a
point in
cubic.
between. Okay.
I need to divide
So
by my
we
new
wanna
power,
take x
and I
plus
had a
1.
negative out front before, so
We
I
want to
need a
subtract
negative.
off our parabola.
Okay.
Squared
There's my
minus
first
2x
term.
minus
I'm
3.
still going to have a negative
all
right
with
here.
respect to x.
Power is going to go up
Okay.
by 1.
Let's go
so
ahead
I'm gonna
and
have a
simplify
square,
this
and then 1/2 is going
for
to be my coefficient
my
because I'm
sanity,
dividing
I
by
guess.
my new power.
And
and then I'm going to have
negative
plus
x
2x.
squared.
This becomes
plus
positive,
c, and then
so
don't
we would
forget
have
this
plus
little
3x,
bar at the end because we're doing a
and
definite
then we
interval
would
now.
have we are integrating from -2 to
Positive 3 here,
So-
plus 1 would be 4.
this is our
Yes.
integral.
And
now
now
we need to figure out,
since we've done so many algebraic ones, let's go ahead and use the calculator
see.
again.
We need to figure
You
out
can
how to
put in
do our
this one
sub in our limits
or
of
this
integration.
one, and you'll
So
get
we
the
want to do the
exact
upper
same
minus
thing.
the lower. So
Okay.
first I'm going to have
So I'm just gonna do the
1
first one to be safe.
So
into
we would
all
want
of
to
my
put
pieces.
in, and then I'm going to
X
subtract
plus 1
off
minus
-2
x
subs in all my
squared. We want parentheses because we're subtracting the entire thing. Minus
-2
2x
cubed
minus 3.
minus 1
And we want to,
-2
I mean, you don't have to
squared
graph it.
plus 2 times
There it is.
-2 plus
Click second, and
There
you
we
might be
you
asking,
can
Miss
see, sorry.
Roberts, why
Okay,
does our
there it
parabola
is.
look different?
Now let's
And
simplify.
it's because we're
so
not
1
graphing this.
cubed, 1
Okay,
squared
we
are
graphed that
obviously all
before,
1.
and
So
we
we
graphed
can
it
just
as
write
2 separate functions.
-1/3
This becomes one
minus
function when we
1/2
subtract one from the other, so
plus
it comes up with
2
something that's totally different,
plus c
but it
for
will
the
still
first
have the
term,
same
or
area
the first
in the
first guy right here.
region that we picked.
And
So
then
we do second
now
trace
here,
to get our
I have
integral
-2,
function.
and I'm cubing it.
Our lower
gonna
limit
give
was
me
-1.
-8.
Our upper limit
So I'm
was
going to
4.
have a minus -8 times -1/3.
And we should get
-8 times -1/3 should give you +8, but then I'm subtracting that. So I should have minus 8
but
thirds.
it's
I have an
nice
odd number
to be
of
able to have the
negative signs here,
fraction.
so,
So quit out of that.
I
get the
should
second answer.
Still have a negative.
You'll get our
Then here,
value from
this
before.
-2
math in our
squared is
inner.
+4.
And you should
Positive
get
4 times -1/2 should give me -2, but then I have another negative, so I should add 2.
squared
I
as
think that was my
our
mistake
final
before.
answer. I will say that if it is
And
calculator
then
active,
here,
obviously
I have
I'm
-2
totally fine
times
with you putting the
+2,
decimal.
so I get
Really, at
-4.
any well,
then I
if
have
it's
this
not
third
calculator
negative
active,
or
I would be
second
very
negative
surprised
right
if you
here.
were using a decimal
So,
mode. You were cheating.
wait.
Yes,
but
so I should get a positive
if it's calculator active
for
go
this
ahead
right
and
there,
decimal
and then minus C.
Okay, so there's those
Let me
examples.
get my other
Good luck with the whiteboard practice.
out.
Send me questions on that, and then
we should cancel out our
answering your questions. I hope you guys have a great day. Combine all of our like terms. So the thing that's going to be easiest to combine first are these things that are divided by 3. Negative 1/3 and negative 8/3 gives me negative 9/3, which is really nice. Then I have a positive 2, a positive 2, and a positive 4. 2 plus 2 is 4, plus 4 is 8, so I'm going to have plus 8. And then I have minus 1/2. I'm just going to keep all my fractions separate for Claire. And then let's figure out what this is. So I have negative 9/3. Negative 9/3 should give me negative 3. That's super nice. Plus 8 minus 1/2. And negative 3 plus 8 should give me 5 minus 1/2, which should give me 4.5. And we can just leave it as that. That's fine. And it asks for area. It doesn't give us units, so we're just going to say units squared. And that would be our final answer. Okay. You can double check yourself on the calculator. So type in our original function to the y equals section. Do second calc. Go down to number 7 with the integrate sign. Click enter. It asks for our lower limit, which is negative 2, our upper limit, which is 1, and it calculates it. And indeed, we get 4.5. We have done this correctly. Okay, so there's that problem right there. I'll let it sit here for a minute so you can see the entire solution. And then now we're going to move on to number 3. Whew, this is a long one. I'm very sorry for the length of this video on all the parts. Okay, so in number 3, it asks us to find the area of the region bounded by the curve and the x-axis. Okay, so if you could just go ahead and graph this real quick. And if you do, you should get a function that looks something like this. Okay, so we're looking for the region that's bounded by the x-axis. That is this region right here, the x-axis and this function, I'm sorry, and this region right here. Okay, 2 different regions. So now if you notice, we have 1, 2, 3 places where we cross the x-axis. If you'll remember, this is going to be negative right here. Okay, we're going to call this our region 2. We're going to call this our region 1. Okay, R standing for region. And we're going to split our integral into 2 pieces. Okay, so our area for this should be equal to our R1 plus, make that look like a 1, the absolute value of our R2. Oops, sorry. Okay, our R2, remember, is going to be negative because it's underneath the x-axis, but we want that whole area, so we're going to force it to be positive. Okay, so the first thing we would need to do is solve for these values. And for the sake of time on this video, we're just going to go ahead and do it on the calculator. So we have x cubed minus 4x squared, but obviously you guys could set this equal to 0, factor out an x, and then factor the quadratic that's left over. You can practice that if you would like, or you can just do this with us here. So here is our little function. Oh, sorry, hold on. Okay. All right. And then we want to calculate our zeros. Another easy way to do this would maybe to be to go to our table and look for where all of our y values, are equal to 0. So notice we have 1 at 3. Oh, we have 1 at 1 and 1 at 0. This happens to be a really nice function. So we have 1 at 0, 1 at 1, and 1 at 3. If they were not so nice, which happens sometimes, you can do second trace and then go to the 0 function. It'll ask for the left bound, it'll ask for the right bound, and ask you to guess. And then it'll tell you where the zeros are. Okay, so either way is totally fine. You also could solve this algebraically, and you would get really nice answers. Okay, so now our function for our area is going to look like the integral. So our first region is from 0 to 1 of x cubed minus 4x squared plus 3x dx. Oh, excuse me.